So let's finish off our theory on floating point numbers by having a quick look at the IEEE standard 754 for floating point numbers. So originally in 1976, Intel began to design a floating point coprocessor. A guy called Dr. John Palmer, who headed up the floating point effort at Intel. He recruited Professor William Mcgowan, who had worked in the 1960s on commercially viable arithmetic methods for computing. Palmer and Mcgowan began the initial synthesis of what would become the IEEE 754 standard for floating point representation. Other Silicon Valley companies joined the IEEE working group. Now we have three main IEEE documents. One was produced in 1985, the other one 2008, and another version in 2019. Now I've left a copy of the 2008 and the 1985 in the resources section, so you can go and have a look at those. I couldn't find the 2019, you'd have to go and have a little look on the internet. I would imagine you could be able to find it somewhere. So that's all we have for our little bit of history. Let's just look at the three main types or sizes of floating point numbers according to this IEEE standard. So we've got a single, which is 32 bits, and that's what we've looked at in this course here. So we've got 1 for the sine, 8 for the exponent, and 23 for the mantissa. Now another thing to note is that the word mantissa is kind of going out of fashion. They tend to use the word significand. Now we also have a double, and a double is 64 bits, and again it's 1 for the sine, 11 for the exponent now, and 52 for the mantissa. There's another one called the quadruple, which is 128 bits, and it's 1 for the sine, 15 for the exponent, and 113 for the mantissa. Now there is another one beyond that as well, but we won't get into that, we'll just stick with these three. So if you were programming in C, you would be able to get access to the 32-bit floating point by using a float. And the double, you can get access to it by using double whenever you're dimensioning your variables. And you can get access to this quadruple if you use the float 128. So that's in C, and it might be different in other languages. So that's all there is for our theory on floating point numbers. What we want to do is take what we've learned and we want to be able to implement it in some program. Once we're able to implement it, it really cements our understanding. So let's go ahead and we'll stick it in VBA first of all, and after we've built something that works in Excel VBA, we'll then take that and see if we can apply it to an actual working example within Logisim. So thank you for listening. I'll get you on the next video. Goodbye.